Practice exam 1, part 2. Question 1. Demonstrate that many people believe that blank is a non-truth functional sentential operator. Okay? So we went over demonstrating what's required in demonstrating an operator is non-truth functional at length in the lectures. So just reminding you of the conditions, the procedure. What you need is, for a one-place sentential operator like this, you need to find two sentences, right, which are going to be the input sentences. You need to find two sentences with the same truth value, where the truth value of the sentence, many people believe that blank, is true when you plug the first sentence in and false when you plug the second sentence in. Because what are you thereby demonstrating? You're showing that, right, so you have two sentences that both have the same truth value. That means they either both have to be true or they both have to be false, right? So you have to conceive of two such sentences such that, right, with the same truth value, let's just choose two true sentences. Still have to think what they are. But what we need to do, the important part, is have it so that the first one, when you plug it in, right, the sentence, many people believe that, number one, many people believe that sentence, whatever it is, that comes out true. But for the second sentence is true, but when you plug that sentence into the blank, for many people believe that blank, that sentence comes out false, right? Because that's what it is to show that an operator is non-truth functional, because what you're showing is that the truth value of the input sentence, what you're showing is that the truth value of the output sentence, right, is not a function of merely the truth value of the input sentence. That's what non-truth functionality is, right? A sentential operator is truth functional if and only if the truth value of the sentence built with that sentential operator is determined only by the truth value of the input sentence or sentences. Okay, so that's the main conditions. Let's just, so we just need to conceive now two sentences which satisfy that. Let's just have 1 equals 2 plus 2 equals 4, right? 2 plus 2 equals 4 is true. Many people believe that 2 plus 2 equals 4 is true, all right? So that's true going to true. For number 2, let's have Dan didn't leave the house yesterday. Dan didn't leave the house yesterday, okay? So that's the second sentence. That sentence is true, but many people believe that Dan didn't leave the house yesterday is false. Not many people are paying attention to my day-to-day movements. This part you can just stipulate. Just have a sentence where it's plausible that many people believe that Dan didn't leave the house yesterday is false, right? Have a sentence like that. And just say, this sentence is true, the outcome is false, right? I'm responding here to one of the comments on the YouTube lectures. Someone was worried about that. Don't worry too much about the truth of, whether we're clear on the truth or falsity of the actual sentences. You can just stipulate, as long as it's plausible, as long as I can sort of believe it. So don't pick a sentence which is obviously false and say that it's true, right, or anything like that. But you can just say, here I am I'm telling you that, I am stipulating that Dan didn't leave the house yesterday. That sentence is true. Many people believe that Dan didn't leave the house yesterday. That sentence is false. Okay? Shh.
Stop!
Guys, shush. All right, so moving on. Let me say, that's for a one-place sentential operator. If you have to demonstrate in the exam, say, that there's that a two-place sentential operator is non-truth functional, then what do you need, right? Well, we did this. We did this, I think, in the lectures. Did we do after? Yeah, I think we did after. That is the operator. So just remember that. It's blank after blank, right? So this is a two-place sentential operator. Build sentences. Put a sentence there. Put a sentence there. Go outside, mate. You Shh. Come on. Come on, I'm not in a lecture right now. Put a sentence here. Put a sentence there. And you build another sentence, okay? Alright. So what do you need? You need to have two pairs of input sentences. Okay, you need two pairs of input sentences, right? Cool. Where they both pairs have the same truth values, right? So you have to have like, instead of this, it's got to go something like this, right? 1, 2, true, 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 where you plug in these two true sentences, it comes out true. Plug in these two true sentences, it comes out false, right? So for after we did, was it Obama is president, and George W. Bush is president. You know, those two sentences, one after two, and for one version, two after one for the other. So you've got true, true going to true, true, true going to false. It's better explained in the lectures if you look at that. So if you've got a two-place sentential operator you have to demonstrate, you just need two input sentences, truth value the same. So again, the motto, catchphrase is same truth value input, different truth value output. Okay, that's just, you need two sentences to plug in for a two-place one. Okay, sorry about the screaming. So that's number one. Just run through the rest of section A here quickly. An argument is sound if and only if, what? An argument is sound if and only if it is both valid and all its premises are true. Okay? And if you want to you should see what valid is. An argument is valid if it's not possible for the premises to be true and the conclusion false. And it's sound if it's that and all the premises are true. So, a sound argument, that's all you need to say for the definition. A sound argument is one you know that the conclusion is true. Right? That's why sound arguments are an even better sense of a good argument than a valid argument. Right? Good arguments are valid arguments, bad arguments are invalid arguments, but sound ones are even better than just valid arguments. They're the ones we want, they're the ones which give us true conclusions. Okay, question 3. A set of statement forms is consistent if and only if. Let me reiterate that for all these truth table concepts, so consistency is one of the concepts from Unit 6. Some of the other questions here coming up are going to ask you about tautologies and contradictions and so on. You've got to think them in their truth table terms, okay? So you think consistency as what? Just picture in your mind a truth table, right? A joint truth table where you've got a set of argument forms, right? Various argument forms. And what is consistency? It's when there is a row, not a column, but a row in the truth table, at least one row in the truth table where all those formulas come out true. Just the existence of one such row is sufficient for those formulas to be consistent, okay? So for consistency, you think row. Different from the other concepts, tautology, contradiction, and contingency, you're thinking of a column, a truth table column, right? A column under the major operator of a form. And recall the big, the opening graph we had throughout the whole of Lecture 6. Be clear on what these concepts do and do not apply to. Tautology and contingency and consistency only apply to statement forms. So you don't say of an argument form that it is tautology or that it is consistent or that it is, right? Validity and invalidity, they apply to argument forms. Consistency applies to what? Sets of statement forms. So be clear about what each concept applies to. Define an inductive argument. An inductive argument is an argument where the premises give you some degree of support for the conclusion. Right? Different from a deductive argument where the premises give you complete support for the conclusion, or the premises necessitate the truth of the conclusion. Complete the following. The major operator for 5a is, of course, the biconditional. Right? That biconditional that's circled there. 5b, A provided that B, provided. Remember, there are a set of words that you need to know that they get translated as symbols, and you need to know for each of those ones. So words like provided, and words like unless, right? And words like just in case, right? Which join the set of words like and, or, and if then, and if and only if. They join those words as getting symbols. Okay, so you need to know for each of those words that they get that the word gets a symbol, that it does get logical representation, and you need to know which symbol it gets. Provided, you just translate as if. So provided is just if. So A provided that B is A if B, so it's B hook A. Right? What follows the if is always the antecedent, so there's that. 5c, the negation of a contradiction is a tautology. So here, right, the negation of a contradiction is a tautology. What you think is, you just think the concept, the truth table concept, right? What I'm teaching it. So a contradiction, you think this, right? A column of F's, right? And now you're asked, what? What is the negation of a contradiction? So if this is a truth table, right, I've got whatever this is the contradiction, this is the column under the major operator of the formula. What's the negation of that? Well, it's a column gotten by negating F each time, so it's true, 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 true. Or 8 truths or whatever, but it's a column of all truths, so the negation of a contradiction is a tautology. That's what a tautology is. 5d, if two statement forms logically imply each other, they are what? They're logically equivalent. 5e, an argument with inconsistent premises is always valid, okay? Because if it has inconsistent premises, there is no possible counterexample, because what is a counterexample? Counterexample is a row where all the premises are true and the conclusion is false. But you can't have all the premises true anywhere if the set is inconsistent, because consistency says there is at least one row where they're all true. So inconsistency says there is no such row. So you can't get the set of true premises you need for counterexample. So an argument with inconsistent premises is always valid. That's 5e. Come back and continue on 6.